Okay, my dear friends, hoping that you are fine with the blessings of Almighty Allah. Last three blocks of this paper we have discussed, and now we are going to solve first three blocks of this paper. This is same October November 2024 and paper 4 variant 2, and let's start it. So first of all, the question number 1, let's see. A rocket has an initial mass of 7.4 times 10 raised to power 6 kilogram. Mass is given. Calculate the initial weight of the rocket. So very simple, W is equal to mg, and it will be 7.4 times 10 raised to power 6 times 9.8. As you will simplify, you are getting the answer equal to it is equal to 7.3. So 1, 2, 3, 4, 5. 7.3 times 10 raised to power 5. No. Just 10 raised to power 7. Check it again. So that is 7.25 times 10 raised to power 7, or you can round it off to 7.3 times 10 raised to power 7 Newton. Dear students, it's already 6, so almost one more, 9.8. Define inverse the term weight. It is the force of gravity on an object, or you can say on a mass. Simple. Okay, now figure 1.1 shows part of the speed time graph for the rocket as it leaves the ground and travels into space. Now see, speed is in meters per second, no worry at all, and time is in second, that is good. Describe the motion of the rocket from O to A and A to B. So from O to A, you can say either increasing speed, or you can say constant increasing acceleration, because slope is increasing. Only 2 marks, so no need to give the reason. More suitable is increasing acceleration, because slope is what? Slope is increasing. And then from A to B, there is still slope, but slope is constant. So speed time graph slope or gradient is equal to acceleration. So if slope is constant, it means acceleration is constant. So I can write here constant acceleration. So this is what? Constant acceleration. Very simple, nothing special. Now draw a tangent to the graph at time 400 seconds and use this to calculate the acceleration of the rocket at this time. Show your working. So 400 seconds, we have to draw a tangent. Even if they have not said draw a tangent, we have to. The reason is, check at 400, graph is not a straight line, it is curved. So here we are supposed to draw a tangent. So my dear friends, I'm going to draw a tangent here. Like this. So that is the tangent. Show clearly on the graph. So what is this value? See, this is 200, this is 400, so in the center this is what, 300, that is x1. And here this one is roughly in the center, so here that we can take 500 and this is x2. Then what about y1, that is 2000, and what about y2, that is 6000. So show clearly on the graph, so that's what we have to show all the data here. This one like this one like this, here also like this. So first of all we will write here that acceleration is equal to gradient of speed time graph, that means y2 minus y1 over x2 minus x1. So this is 6000, y2 2000 is, y1 x2 is 500 and x1 is 300 if I'm not wrong. Let's confirm. 6000, 2000, 500 and 300. Yes, Mariam, you said answer is 20. Yes, okay. So answer is 20. So here we will write as you told 20. So I'm just following 20 meters per second square. Yes, Mariam, it's okay. 20 meters per second square. So if for this question, of course, there will be range of the answer. There will be what? Range of the answer. Now, rockets are used to launch satellites into the space. So when the satellite is released, the rocket returns to the Earth. Explain in terms of the forces why rocket reaches terminal velocity as it travels through the atmosphere back to the Earth. It reaches terminal velocity, 2 marks are there. So one point will be weight is equal to air resistance, so that resultant force 0, acceleration 0, or terminal velocity is reached. But I will be writing now that air resistance on rocket on the rocket increases as its speed increases, because air resistance is directly proportional to speed. 1 mark you have scored. So write next point that when I'm writing my shortcut, air resistance becomes equal to weight. This implies that resultant force is equal to 0 and rocket reaches terminal velocity. Even in bracket, if you want that, you can write 0 acceleration. That can be the answer. If there is any doubt, any question, any ambiguity, please feel free. You people can ask me now. Feel free, you people can ask me now. Okay. Then next question is, figure 2.1 shows a golfer about to hit a golf ball with a golf club. The initial momentum of the golf ball is 0. So PI, let me say the initial momentum is denoted by letter P, and I for initial, that is equal to 0 because ball is at rest. Define momentum first of all. So momentum is the product of mass and velocity. So I am writing simply it is the product of mass and velocity. The golf club is in contact with the ball for this much time. So this is the time of contact of the golf club with the ball. The velocity of the golf ball as it leaves the golf club is this. So this is the final velocity, because initially it is at rest, initial velocity is 0. The golf ball has a mass of this, and mass is also given in System International Unit kilogram. Calculate the impulse of the golf ball. Now you know impulse has two equations. Impulse is equal to force times time. We don't have the force. Another formula is impulse is equal to change in momentum. Impulse is equal to change in momentum. Now, which means mv minus mu. Mass of the ball is 0.046 and velocity of the ball is 41, minus mass of the ball 0.046 times 0, because initial velocity is 0. So when we will multiply 0.046 times 41, we are getting 1.886. So I can write it 1.89, or even we can write here 1.90. Impulses can be written kilogram meters per second or Newton second. In any way, it's okay. Then next is calculate the force required to the ball, force applied to the ball by the golf club. F is equal to rate of change of momentum. We can write mv minus mu over t. So mv minus mu, we know this is 1.886. You know, change in momentum we have already calculated. Over time, how much is the time? That is 5.0 times 10 raised to power minus 4. So when we are calculating it, we are getting the answer, see, 1.866 divided by 0.0005. So it is 3772. Yes, Mariam, correct, 3772. So it is 3772. We can write it simply 3800 to the nearest 100, or 3770, that will also work. Even you can also write 3770, but you are not going to write 3772 because 4 significant figures we are not allowed with. Please, my dear friends, even you can also solve it. F is equal to ma. Mass, take the mass as common, then a is v minus u over t. Still the same answer will be there as we have discussed now. Okay, now next one more question is on general physics. State 2 energy resources for which radiation from the sun is the main source of energy. 2 energy resources, many are there, even fossil fuels. So you can write fossil fuels, then hydroelectric, wind energy, waves, anything you can say, solar panels, solar cells. So let me write solar panels. Yes, hydroelectric, wind. Mariam, exactly, you are right. Emma, you are not answering anything. Muhammad Tariq, Muhammad Jamal, only Mariam is in the lesson, rest are sleeping maybe. So wake up now. A wind turbine is used to generate electricity. The useful output from the turbine in 1 second, so time is given is 6000 joules, so this is output energy. The kinetic energy of the wind hitting the turbine in 1 second is 11,000 joules. The velocity of the wind hitting the turbine is this. So show that the mass of the air hitting the turbine each second is approximately 550 kilogram. Answer is given. And in general, when some sort of question comes, so we are given with the volume and density. Here no case like volume and density to get the mass. Then what can we do? Then we can use kinetic energy. Ek is equal to 1 over 2 mv square. Now we know mass will be equal to 2 times Ek over v square. Then mass is equal to 2 times kinetic energy, which is 11,000 joules, over speed, which is told 6.3, but not only 6.3, we are supposed to calculate its square. So my dear friends, answer will be now 2 times 11,000 equal to this divided by 6.3 equal to this again divided by 6.3 equal to 554. So what is the answer? Answer comes to be 554. So we can round it off to 550 kilogram. Please attentive here. This is a bit out of the way question and out of the way formula. As I told you, this is very common. In general, to get the mass, density is given. Either it is electricity question, even it is space physics question, it is in nuclear physics, it is here in general physics. But this time, I think maybe second time this thing has been repeated. We are given with kinetic energy and speed. So if they are asking the mass, no need to worry. We know kinetic energy equation as the mass 1 over 2 mv square. So make mass as the subject of equation and then calculate it. Okay, now calculate the efficiency of the turbine. You may assume that all the kinetic energy stored in the wind is transferred to the turbine. So efficiency, we know efficiency for equation we will write first. I'm using the shortcut, that is useful output energy over total input energy times 100%. Now useful output energy, see, useful output 6000 and all the kinetic energy they told is the input energy as transferred to 6000 over 11,000. And many times I have told you that whenever we are calculating the efficiency, numerator value magnitude is smaller and denominator magnitude is bigger. The reason for that, there is not a single machine or a device invented or made which is 100% efficient. It is an ideal approach that some device is considered to be 100% efficient. So when we are calculating it, 6000 divided by 11,000, we got 50, no, times 100 also. So it is 54.5. 54.5. So we can write 55% even. So I'm writing here 54.5. So we can round it off to 55%. Okay, Mariam, nice. Then next is the tidal energy and wind energy are both renewable energy resources. Suggest one reason why tidal energy is more useful energy resource than wind energy. Ignore the cost of construction and maintenance. 1 mark is there. So wind is not reliable. you can write like this. You can write wind is not reliable, or it is not supplying a constant supply. Always the supply of the wind is variable, so we can say wind is not reliable. Or you can say reverse of it, you can say tidal energy is reliable. Any one of them you can write. Why it is reliable? Mean the full days of the moon, you will see that wind energy, this tidal energy will be available. We cannot say that it's not this way or the other way. It will be there available as compared to wind energy. Of course, if there is weather like a cloudy weather is there even in the night, so then moon will not be shining, so that, but still it will not be that much affected. So if we are making a comparison between the wind and tidal energy, then tidal energy is more reliable, or you can say the waves, they are following some sort of regular pattern. Wind is not following ever a regular pattern. So anyway, any one of these two statements you have to write, not both of them. My dear friends, if you have any question regarding this, please feel free, you can ask me. Okay dear friends, stay blessed.